Welcome everyone to the Asphalt Plant Inspector training. So my first slide here, I just want to go over what the definition of standard specifications are. And it's just a compilation of written requirements for performance of the work, provides requirements for the quality of materials provided, provides description of the equipment necessary to do the work. And as an asphalt plant inspector, I would recommend that you familiarize yourself with all the areas that would pertain to HMA pavement. And some of those sections would be like section 154, which is the equipment section, and section 109 and section 706 is field labs, and certifications is 109. And then the general hot mix asphalt specification is section 430. And then the material requirements are section 800. So it would help for you to spend some time to read these sections, because basically everything that's out there today and everything that's done is really in the standard specifications. The other manual that we want to make sure that we know about too here is the field sampling and testing manual from the that's published by the North Dakota DOT in the materials and research section. And this should be also by your side in the lab, and it's going to basically tell you what type of materials that need to be tested, what types of tests that need to be done on them, tests, make sure they're run correctly, and how often. And then there's protocols in there also about how to proceed when tests do not correlate with the contractors. And there's random numbers, ways to do random numbers in there too. So there's a lot of great information that this should be at your side. So the role of an inspector. Inspection is one of the most important processes in any highway project. Quality of the finished product typically reflects the quality of the inspection performed. An inspector must be honest and fair, exercising responsibilities with firmness and good nature. The inspector must work cooperatively with fellow employees, supervisors, and contractors to promote the progress of the work. And then communication between the asphalt plant inspector and the asphalt paving inspectors is very important. There are a number of things that both should know at the same time, and there are lots of things, and they should be in continual conversation throughout the day. For example, if there's breakdowns at either location, or how many trucks are perhaps on the road, or how much mixes have been put out already. Things like that. So it's only good to be able to keep in good communication with the asphalt plant or paving inspector as well. So some definitions. Hot mix asphalt is probably our only full-fledged quality control, quality assurance specification. And there's a few definitions that it'd be interesting, because we kind of use them through the presentation here. So quality control is mixing and placing of the HMA ingredients in a prescribed manner so it's reasonable to expect the pavement to perform properly. And that's the responsibility of the contractor. And the quality assurance is the assurance activities necessary to provide confidence the HMA pavement being constructed will satisfy the given requirements. And that's the responsibility of the engineers team, including the asphalt pavement inspector. And independent assurance is the unbiased and independent evaluation of all the sampling and testing that's going on out there and used for acceptance. And that's the responsibility of the district materials lab. An asphalt plant, what does it actually do? The purpose of an asphalt plant is to blend the aggregate, binder, and the additives used together at an elevated temperature to produce a homogeneous mix. There's several types out there of plants, and years ago you probably saw more batch plants, as you see over to the left here. But now you see more the drum dryer types, and there's a parallel flow and there's a counter flow. Mostly what you see out there is parallel flow, like this one here. And it has about, just an overview. You've got your stockpiles that I've made earlier. And then you've got your cold feed bins that all of the different stockpiles go into. So you've got an aggregate supply system, and this belt here actually is combined, or like the charging conveyor that has the cold feed coming up to the drum. And you've got the drum dryer itself that mixes, and all the ingredients together. Here's your wrap. Recycled asphalt pavement is something that we're using more of these days. We're trying to save on our aggregates, as well as the asphalt residual binder that's in the wrap is used also in the mix. And then we have our asphalt supply system over here. Have emission control system, takes care of all the exhaust, and then some of the dust gets collected here, can be put right back into the plant. And then once the material or the product is made, it goes up an elevator into a surge silo, where it can be deposited into the delivery trucks. And so just a little bit more on that. I've taken some pictures over the years, and so even before these asphalt projects start and during the project, there's a lot of processing of the aggregates. This is a crusher over to the left, and it's making the stockpiles of rock and crusher dust, the byproduct of crushing the rock. And there's also, we use a lot of some of the screen material back into it. The pictures at the bottom here are of the recycled asphalt pavement that is most likely been milled off the pavement prior to the overlay or whatever going on it. And so that also has to be treated like an aggregate material too, except that it has some binder in it. So that's a special part of that. So once the stockpiles are made, then the project starts. So this is kind of the main workhorse out there that does all the delivering from the stockpiles to the separate bin splits on the plant. And it's actually quite interesting to watch once in a while how they can actually, usually one of these can be used for just the whole job, and they really get their work out of these things. So once the material is in these separate bin splits, all the different components, as you can see over, there's a schematic I have onto the upper right here, and that every one of those bins you see to the top left there has got something like a schematic like this underneath it, and it's actually depositing on a conveyor at a certain rate. If it's 20%, if it's all these materials are 20, 15, 20%, whatever it is, they have to gauge that. It all has to be calibrated to make sure that it puts out the right amount. There's also moisture. What complicates it a lot is the fact that there's moisture in all this. So that has to be allowed for. The bottom two pictures are just photos of once the material leaves those aggregate bin splits, it has to go on like a scalper. And these scalpers have a certain size. I think it's like a half an inch or something that it has to be more than the actual gradation, nominal maximum size of the gradation. The main purpose here is to get the oversize off it. And there's actually one like this for the recycled asphalt pavement too. So once it actually gets up makes it through the scalper, then it's going to go up this conveyor here. And this is the main conveyor that has all the aggregates on it. It's all combined. It's what some call it the cold feed belt, but some will call it the charging conveyor. That's the one that's going to lead up to the drum. And you can't really see it very well, but on this particular conveyor now, there's actually what they call a weigh bridge. And this weigh bridge actually kind of looks like the one up here in the top up here where I have the pointer, but this weigh bridge will actually weigh it at an instantaneous value, what's going over on the belt. And then there's another mechanism here that actually times it for a certain time. And then there's a totalizer at the bottom here where actually totalizes it all up. So you actually get a rate, and like, for instance, tons per hour. And that's an important term in the asphalt is a rate, because everything has to be geared to certain tons. Moving on, then once it gets to the dryer, then with a parallel flow, it actually hits the heat right away, and this can be up to 1400 degrees Celsius. And this, when it actually hits the burner, is the burner over to the top left here too, showing it from the side. And then the drum is tilted, and it helps in getting the aggregate to flow through more of a gravity, has gravity working for it. And so it probably spends, 4, 5, 6 minutes in the drum, the aggregates, depending on the moisture. And there, you can see over here to the lower left, there's what they call flights, and they have to make sure these things are in good working order. It's kind of like your dryer at home. It revolves and it has flights in it. And the reason why is it catches the clothes, and in the case of the aggregate, it puts it in kind of a veil or thin sheets, and then the aggregate can, or the burner can actually dry it a lot better. Over here, over to the middle left here is the wrap conveyor. It's just like and that has a weigh bridge on it too. And it's dumping in the wrap recycled asphalt pavement into this wrap collar, and that's about 2/3 down the burner. And the experience has shown that if they run the recycled asphalt pavement through the burner, it will burn off or damage the residual binder that's in it. So they feel like they could, downstream, they can be added, and then it can all the other hot aggregates will heat it up pretty fast. And this is just a photo that was taken a couple of years ago that we had of this same drum that's up at the top here with a thermal camera. Showing all the different temperatures as it's going. If you notice when they actually put the wrap in, that it actually cools it down, because 20% of wrap at say 70 degrees actually cools it down fairly fast, but it warms up enough before it gets all mixed. So here's the asphalt supply system, and that's quite a interesting thing of itself. Basically all the binder is trucked in by transports here, as we see. And then it's pumped into these heating tanks, and they get up to, they heat them up to around 300 degrees, somewhere in there. And then there's a pump system here that actually pumps at a certain rate into the plant. And you can kind of see a little bit here, the little green pipe that goes in, it actually goes into the back of the drum. And this is all hooked up to the computer in the control shack. And it'll tell you, how much, what the rate is. For instance, in this case, it's a certain amount of tons per hour. This is just a schematic of one of these tanks. And actually, up to this day yet, we still call stick the tank, and that we do that at the beginning, at the end of the day. So we know how much asphalt was used during the day. We also can keep track of it with totalizers, with the totalizer that will show up in the computer. And so here's the bottom right is you can see this is where the binder comes in, the hot binder, and it mixes with the hot superheated aggregate and wrap. And that's where all the mixing takes place, maybe about 10, 15 feet. And then it's all ready to go and goes out the delivery. This is just something that when you have material that comes to the plant, it comes in gallons, hot gallons we call it. And so asphalt cement expands when heated. The volume of the asphalt, 300 degrees, is a greater volume than at 60 degrees. So these two schematics I have here in the middle, one is hotter and it's taking up more volume, but it still weighs the same. So we have to when we buy asphalt on these projects, we do it by the ton. And so before the asphalt can be used in the plant, it has to be adjusted to a volume of a standard temperature at 60 degrees Fahrenheit. And actually at 60 degrees Fahrenheit, you can't even, the binder is like, you can't pour it at all. You can hardly stick your finger into it. That's how it is on the road right now. It's stiff. And so that's how we buy it, though, at that particular temperature. So a gallon of that has a certain specific gravity at 60 degrees. And as we'll see, so I've got a little example problem here. For instance, say a transport loaded at 5,000 gallons comes to the site. It's 300 degrees, the temperature. And so how many gallons of AC in the transport based on the standard temperature? And that should say 60 degrees Fahrenheit. So this first thing is you've got your truck over here and it's got 5,000 gallons in. So you're going to want to reduce that down to a standard temperature of 60 degrees. So in other words, the volume is going to go down and the gallons. So actually you go to your pocketbook of useful information, and you can get the correction factor that will bring it down to a certain temperature, reduce the gallons of it in there. So actually this truck now, if it was reduced down, if it was all cooled down to 60 degrees Fahrenheit, you would only have 4593.5 gallons in it, which isn't a whole lot of difference, but it's enough. Now in B here, we want to know what the tons are. That's what we really want to know, because that's how we buy it, is in tons. So the specific gravity for, we'll just use this as an example. It varies a little bit, but it generally is around 0.030. And so the specific gravity of water is 1, and that's the water is about 8.34 gallons a pounds per gallon. So we just take the 8.34 times 1.03, and that'll give us the actual weight of the binder in a gallon. If you put the binder in a gallon container, it would weigh that much, just a little bit more in water. And so just going through the calculations, that your gallons would actually, times the pounds divided by 2,000, would actually give you the 19.6 tons. So that's how much 5,000 hot gallons weighs, 19.6 tons. That's how you figure that out. Moving forward here, I'm going to just kind of talk a little bit about the calibration of the plant, because an asphalt plant inspector should know about the calibration system. And it's a good idea for the inspectors to, at the pre-job or sometime, to let the contractor know that they want to be out there when they're doing this stuff, because it just gives them more assurance then when the plant starts that things are in good shape. There's a lot of things to do on these projects before the job actually starts. So in the case of the asphalt, it's very important that the supply system, the whole plant itself, is delivering the right amount of material to everything. And so as far as the asphalt is concerned, the way they calibrate it is they've got, once again, we've got the tanks now, they're, the hot gallons. So the pump is going to pump all this out, and it's going to meter it, and the computer is actually going to reduce all that down to what we need, like we just did in that example problem. It actually takes these hot gallons and turns them into it reduces it down to the 60 degrees Fahrenheit, and then it takes it times the weight, the specific gravity, and gives you the tons in here. So these numbers here are the bottom one here is the tons per hour or whatever it was. And so in the same process, though, at the same time, what they do is they just take a tared truck, for instance, and they run the oil into the tared truck, and then they go weigh it. And then if they're within, say, 1% or whatever the tolerance is, then that's good. I mean, whatever was metered and shows up on the computer, whatever was weighed physically, should be very close. If that's the case, then things are good that way. They do the same thing for aggregate. And once again, before this conveyor, here's your charging conveyor going up to the drum mixer, and they have the weigh bridge on it. It weighs it, sends it to the computer, tells you the rate that it's working. So then also they can physically do this again with, say, a truck box full, and go and weigh this, and it should be very, very close to what's actually metered on the computer here. So that's how they do that. And then when you put it all together, this is where the computer really comes in, because everything has to talk to everything. For instance, the aggregate, the computer senses how much aggregate is being brought up, and it also allows for moisture. And so then it talks to the pump, and the pump starts to deliver what they need. Now, the meter is going to be checking this all the time and getting information back to the computer. Sometimes the temperature might change in the material. And if that's the case, then that means that, say, if the hotter this is, the less weight is going through of it, because it's expanding. So they have to do some adjustments, one way or the other. It all has to talk to each other. It's amazing, these new plants, how accurate it is once they get this whole thing calibrated. And the main reason they're calibrating this, a whole system here, is because if you want 100 pounds of mix going out of this drum up into the truck, you want exactly 94 pounds of dry aggregate and 6 pounds of, or 6 tons of binder. And so we don't want it to change anything. At the end of the day, that's what we want in there. We have a little bit of tolerance that we'll allow, but that's it. It's to their benefit that the plant is calibrated. And so this is the last segment, basically, as far as the plant is concerned, is once everything is made, this is coming out of the drum, it goes up the conveyor, and it's ready to be, this will hold quite a few truckloads, and then the trucks just go under and take it to the plant or to the site. So, okay, we'll switch gears just a little bit here, talk about one of the first things that the engineer is going to want to do is when they go in to put personnel on their project is to assign testers. And this is important because if that does not happen, the testers and inspectors can't access the materials drop box. So that's important first step. So inspector duties, primary responsibilities to ensure the acceptable quality of the bituminous mix, continuous testing for quality and uniformity of materials used in the mix. So the separate things like the aggregate, and then we also check the final mix as well. And so there are many, besides this, there are many other important duties to be familiar with, which we will talk about here. One of the first ones, I think, too, is when we arrive at the plant, is to make sure that we get all these scales. There's scales everywhere. So we want to make sure that we get all the scales have been certified by a reputable company. And so that's very important. And then field laboratories, this is where you'll be spending most of your time. On these QC/QA projects, there's two labs. There's a contractor lab and there's an engineer lab. So the contractor, this comes right out of the specifications, basically, that they have to have a lab that they can do with the equipment necessary to do the QC testing, and includes a gyratory compactor. It also they have to do all their functions in that lab and not the engineer's lab that we have. And so the inspector, we have to share the gyratory compactor with them so that we can do our tests too, our verification tests. Then the contractor has to place the laboratory that we work in, the QA laboratory, at a site near the contractor's laboratory, and where it does not interfere with the lab or the plant operations, like the vibration and stuff. So the engineer will have full control of that laboratory, and as an inspector, you must, when you get on site there, you want to make sure it's in the proper place and mounted on a firm foundation and level, and make sure that it's safe, the railings and the steps going up, that it meets all the standards. Like there's a standard for what a 706 there, what the laboratory, the measurements and the dimensions, what they are. And so it's a good thing to look at that. And this is a good thing to talk about at the pre-job. How's the lab? What is, maybe even have them have a picture of the lab. It should meet all this before it even goes on site. And then we want to make sure we go through, once we're in that lab, we want to make sure we go through with the contractor or the QC inspector, somebody, to make sure that the condition of it before and after. It's a good thing to do. So moving on from there. So in our laboratory, or the QA laboratory, the contractor will have to furnish some equipment according to the specifications, some of the bigger equipment, like the shakers and the ovens and water baths and things like that, race equipment. Some of the things that we have to provide are like sieves, or like the district materials lab will have the sieves and scales and flasks calibrated and everything, and the FAA equipment, the sound equivalent, things of that nature, all the other miscellaneous stuff, thermometers. The contractor has to provide with these labs and this equipment that they're providing, it all has to be calibrated and certified according to the quality laboratory program. And then they also have to provide testers that meet the testing certification program, North Dakota DOT. And so the inspector will want to verify all that, make sure that all the equipment is in good condition, and that all the testers have been certified. They can go online here at the online registry and find that out. And this is another very important form that we should be filling out and that is, and you can work with the inspector can work with the district materials lab to go through both labs and get all the certifications off these equipment and make sure we list it. Make sure it's all listed and everything is certified. That's very important. And so then another thing in the specifications that the contractors needs to require is quality control plan. And this is something that, you know, they have all, basically will have all the names of the people involved in the QC program, inspectors on the road, testers, who's in charge of the control of the mix. And so, and then there's details, should be details like for pit operations, and they even will, you know, have a kind of like a site layout, which is a neat thing. What are they going to do if something goes wrong? How are they going to keep the aggregates from getting segregated? It should all be in there. That's something that we should make sure we're familiar with as an inspector, and that we make sure they're in the labs. And then another thing is the engineering quality control plans. That is not near as involved, other than the fact that they want to make sure, you know, we give the contractor access to all our phone numbers also, and that should be in the labs. One of the things, once you get all this stuff done now, and you finally get sat down in the lab, you can actually look at some of these things that on the mix design as you can get a lot of it just right out of the cover sheet to start with. But the contractor has to provide us with a mix design before we start, and then the district materials lab verifies those mix designs to make sure they're ready to go. And so hopefully that's all been done, and you have a copy. And so there's a couple of, so we're basically, a mix design is just the objective is to determine the combination of AC and aggregate that will give a long-lasting performance of the pavement. So the final goal really is to select a unique asphalt cement binder that will achieve all of the balance of all these properties we want it to meet. And there are a lot of properties with SuperPave. So I just want to go over a couple of things from the summary here, just kind of highlight them here. So the inspector is going to know what kind of binder they're going to use on the project. They're also going to know what gyrations. Now, this has been fairly standard 75 here for many, many years to run these gyrations that, like in the gyratory for the mix. But nowadays, there are a few jobs out there that actually have less than that. So you want to make sure you check that. And also, this particular segment here talks about the total amount of material that's in, or asphalt cement that's in the mix. And this may include any residual binder that comes from the RAB, or the recycled asphalt binder. And so this, and the rest of this stuff here basically is showing that it meets all the specifications. This area here will tell you here, for instance, now this project actually did have, the example I showed here actually does have some recycled asphalt pavement in it. The total 6% that we showed in the previous slide, well, 5% is going to be virgin add oil, and this will be your target. That when you start the job, the contractor is going to have to adhere to that, unless there's some sort of target change later on. But they'll start out with this, and that's what they want to put in the mix, 5% by weight of the mix. And so another thing you want to get is some of the specific gravity information here to start with, so you can do some of your physical property testing with it. And so this is the blends that are used, and it's a good thing to make sure that these are the blends they're going to start with. And if not, then you need to communicate with someone to find out why we're not starting at these. But here we have all the different components. We got some dust with rock, things, natural fines. We also have our recycled asphalt pavement, which is 15% of the mix. And this sheet here, and I will just basically talk about this virgin gradation here. This is a target value. This is a result of probably months of testing, quality testing, control testing that the contractor done during the production of the aggregates. And so they're pretty confident that this average is about where they're going to be running on their tests when they do gradations out there. And so and we're going to be doing gradations here too. So what we want to do with that now is there's a table in 430 that talks about single test and moving test averages. If we expect the contractor, for instance, to run and hit these values right on the button, it isn't going to happen. And the reason is because the inherent variability of the material. And so we will tolerate or will allow a certain range for them to work in. And that's what this is, the single test control limit. Now, we don't take every sieve here either. We just take control sieves. The control sieves for super pave is 1/2, 4, 30, and 200. So those are the only 4 you need to worry about. And so what we do then is we take this, and this is something that you should do for your own good. It might be done already by the contractor, but to make this little table out, and for instance, on the 4, we would round that off to 54, and then you would go plus or minus 6 of that. So this is the range actually that the contractor will work in when they do gradation, and you too, as an inspector or tester. Now we'll get into some of the testing here. The contractor, this is right out of the spec pretty much, that the contractor shall perform random QC sampling and testing of aggregate and asphalt mix as specified in the testing manual. And so what they do for every test they take, and they're going to do most of the testing out there. They're going to take splits. They're going to split it in our presence. And they're going to take that split and they're going to go back and run it. The other half, they're going to give to us. And all we do with this is we put it aside and make sure it's secure for a certain amount of time here. And if all the tests work out, then we can get rid of it. We don't test this one. This is just a split that gets set aside. And so speaking about getting samples, we want to make sure that we know where the aggregate sampling devices are at the plant and what type of sampling device. And we want to make sure that we approve this before it starts. The engineer has to approve these sampling devices. The frequencies for these tests, the contractor is to run, mix and aggregate samples about every 1,500 ton. And they have to also take samples for physical properties. And one thing that has changed now recently in the last few years is that the contractor will generate their own random numbers. We used to do that, but we don't do that anymore. They generate their own random numbers and they decide when they're going to go take a test. We have to know when they're going to take it. They have to tell us, or they have to give us a copy of that. As far as we're concerned, we're in the business for, as we talked about earlier, is that we're in the business of verifying this, making sure that, assuring us that the quality is being done right. So we have to take some tests too, and it's a lesser amount than the contractor, but we have to do it to verify that everything is working good. And so we have to get a separate test. A QA and a QC lab have to get separate tests. It cannot be a split. Now, we talked about the split earlier, but that was just for setting aside and not using it, just setting it aside in case there's some dispute. The test that we go out to get, we generate our own random numbers, the QA people, and we have a kind of an increased frequency for the first few tests, and then we can go down to once a day, but they have to be, I have to stress that it's separate. It's not a split. Sometimes what happens is that the QA and the QC kind of go out together and get their tests right side by side. That's really kind of a split. So the asphalt inspector should get their own random numbers, and they should go out whenever it says that they can go out to get them. It might be an hour, 2 hours after, or an hour or so, whatever, between when the contractor took it and when they did. So that's what keeps it all random, and that's a very important thing to know, is that everything has to be separate. Contractor, while they're taking these tests, they have to they have to write everything, they have to document everything, they have to maintain control charts. And that's something that, and they have to be available to us as inspectors to look at. And so one of the things inspectors should do is verify that all the tests are being done, of course, and verify that control charts are accessible. They have to be accessible to anyone that walks into the QC lab, be able to look this up. It's easier when you get a bunch of tests going. it's easier to see what's going on with what they call a chart like this. And there's several of these charts. There's one here for air voids, but there's 7 or 8 more types. There's all the sieves have them, and then all of the like physical property things and all some of the mixed things. So it's better if you have a chart, because then you can see some trends going on. Now that's the whole idea behind it. If you see some trends that aren't working very well, communication is number one. You want to make sure that you're talking to everybody, engineer, district materials lab, and of course the contractor. Why are these things trending out or trending towards the limits? So between the two labs, if the asphalt inspector's QA results are within tolerance, the contractor's results are accepted. And that's how a QC/QA operation works, is the contractor's numbers can be used as acceptance as long as the verifications are within tolerance. And so what happens if something doesn't work out? What's the protocol for that? And that's in this field sampling and testing manual, the procedures for that. So I recommend read over all these things, especially section 430 of the testing manual, because you're going to use every bit of it. And the same thing with the specifications. And so there are 2 different things that can happen out there. The QA and the QC can go out of tolerance, or the QC testing itself is not in the limits. And so there's a couple of different things, but these sort of lead to the same thing. And so if the tests are out of tolerance, if your QA tests and QC tests are out of tolerance as per the tables that are in the testing manual, then what normally happens here is contractor has to resample, but when they resample, this is where the materials district lab comes into play. They get a 3-way split. Now we're talking about a split of aggregate, not a separate sample. We're talking about a 3-way split between all the parties, and then that gets run, and then we determine what the discrepancy is, and then we move forward from there. So we're trying to do is troubleshoot this. And it's best to try to do all this as fast and as efficient as we can, because we don't want to let the problems get away from us. These plants put out a lot of tons, and so we want to make sure we get stuff straightened out fast, and get things back rolling normally. And so now we're kind of getting into more of the contractor part of it. If their tests maybe start to go out or something, so they have to adhere to these single tests and moving averages. So a single test is basically what it says. It's just a single test, and it has a wider limit than as you can see, than a moving average limit. A moving average limit target value is a little bit different. It's determined using the last 4 recent single test results. And it has a narrower limit. And this is the one that we really want to watch out there, is the moving average one. So here's just a typical, as we had earlier, the air voids kind of blew up here a little bit. The red marks here are actually the single test limits, and they are wider, as you can see. Whereas the moving average, once the job gets going and you get a lot of tests, this is the one you want to watch. And that has a narrower limit. By the way, this one here is the moving tests, when they start to trend out, they're much harder or more difficult to move back the other way. So you don't really want to wait for those to get out, because you might have 2 or 3 tests after that trying to get out of, into a better range. So you want to kind of be more proactive with these moving average ones. So if a single test exceeds the limits, the contractor shall immediately take corrective action. Once you got your test result, they got their test results of this out, then they're going to want to do some type of corrective action, and then they want to sample and take another test to see how that turned out. And if that passes, that's great, and then we can get back going. Now, that particular test they used to do the correction, that cannot be used. That has to be set aside now, because it can't be used in the moving averages. That's basically just for correction. And so as an inspector, then we need to be notifying the engineer that this stuff is out, the district materials lab, and then make sure we document what corrective action the contractor took, and keep monitoring things and moving forward, and hopefully things will work out there. If moving averages go out, it's pretty much the same thing. However, you don't really want to wait for them to go out. In other words, this one here says trends toward. So you want to kind of be more proactive, as I said earlier, in trying to fix those. One of the things during the project that the contractor is required to do is take readings of the totalizers that we talked about earlier in calibrating as the job is going through. So every time they take an aggregate test, a QC test, they're required to go in and get these readings off and in our presence, the readings off the totalizer. These are all in, and over to this computer here, these are all in tons. This is tons per whatever time it was between the last reading and this one. And this all has to be entered onto a form called the Asphalt Content Virgin Aggregate Determination. So really what this is all about is, at the end of the day, we're going to want to know how much binder we used in the mix. That's going to come from our tank sticks. At the end of the day, we're going to figure out how much asphalt binder was used. But we also are really concerned about variability during the day. If we want 6%, for instance, in the mix, we don't want it to be varying at 5.5 and 6.5 all day long. We want it to be we want to be hitting, 6 or whatever it is, or 5 or whatever the target is, pretty close to that. And so that's what this form does. There's the form here that we're talking about. And this one, every time you do a test, and this is the asphalt content and virgin aggregate determination. So every time the QC takes a test, we have to get readings off this. And so these 3 readings, one of them, the top one here is the aggregate, and then the middle one is the wrap aggregate minus the binder that's in it. And then the bottom one here is actually the tons of asphalt that's been used. And so all this gets entered on this form, and then you could just a simple formula to figure out what is the actual, how much binder are we actually getting in it. And you can see this is actually running pretty close here for this particular project. And so all these numbers are put in here. And so if this varies too much, there's actually a penalty that has to be given. So contractors motivated to keep this very uniform. And that's why they calibrate the plant, is to make sure all this is doing well. So one of the things then also is compaction. Is at the end of the day, Brian is going to go out, for instance, or the paving inspector, and mark out cores, and then the contractor is going to core them in our presence, and then we're going to take possession of them and bring them into the lab, and then there's going to be a little bit more processing, but then finally we're going to test them for the bulk specific gravities of these. And then what we do is we take that information. For instance, this one has a station 344. Then you enter that in here. I just entered one here on this form, and this is actually done with the paving workbook. And then it figures out what your density is. Now, the bulk itself isn't going to do it for us. We have to have the RICE test, or the maximum theoretical density average for the day. There might be 3 or 4 of these done, and they're all averaged together. And this is usually the contractor's number. And I say usually because if our tests indicated that the quality control tests that the contractor did were in tolerance, then yes, we will use the contractor's numbers there. And that's what is used to compare the bulks. And then here you will get a density. So one of the things also that we want to make sure that we get samples of are the binder itself that come in these trucks in the transports. And we have to do that. They have to do that in our presence. We have to make sure they're labeled and manifests are put on. We want to take possession of them, and then we send them into central lab for testing. So some other duties, and more of a visual thing, is occasionally you might you want to make sure that it doesn't. You want to go into the QC lab and watch them do some tests, and watch for evidence of blue or dark smoke. That means the mix is getting too hot and starting to burn off some of the binder, damaging the binder some. You want to develop a good mental picture of what good proper mix looks like, so that you can make sure that everything is looking good, and you want to be checking the temperatures of the material, and visually inspect the components of the plant, and periodically check the scales for accuracy in the labs and things like that, and visually inspect the stockpiles for segregation. Inspection diaries. We want to make sure that an asphalt plant inspector is an inspector too, a tester, inspector's inspector, just like any other inspection. And we do inspection diaries for all our other things. And so it's always good to do an inspection diary. And I only have a token amount of things down here. It's something you want to talk to the engineer about what they really want. It's when you're filing these jobs, or if you're trying to figure out what happened one day, it really helps to have an inspection diary. Laura talked about all the paving workbook forms and things, and they all that workbook can really do a lot of things as far as calculations, and it's amazing the amount of things it can calculate, and it calculates the whole cutoff report for us. And as long as we put the inputs in, every once in a while, just for my own good, I like to just run through one of these myself and kind of break it apart and kind of do it by hand. And it kind of is good that way, because if something goes wrong, and sometimes it does, not very often, but sometimes things don't work out, you kind of wonder why. So I just want to go through one real quick. Basically what we get, this is kind of the heart of the things that happen out there as far as the binder's concerned. It tells you two things: quantity of binder that you use during the day, and it also tells you the percent of binder in the mix that was. Now we have a range. If we started with, if we want 5% in the mix, we want to end up with that. We want to do this cutoff and find out those two things. And so I kind of broke it down in segments here, and it's just going to kind of talk about each one a little bit. So the first one here is the beginning of the day. The contractor is going to want to, as I mentioned earlier, stick the tank. And that's going to tell them how many hot gallons they have. Now, the plant, a lot of plants, they have several plants out there, or several tanks full of mix. They want to get readings from all of them. And this is actually the first section of the cutoff report. And so they enter all those hot gallons in there, and they know the temperature. So then they go to their pocketbook, or our pocketbook. We used to have to do this stuff by hand, but now this is all in the paving workbook. But anyway, you put down your correction factor and bring it down to a volume of 60 degrees. So all these are smaller than what is over here. And then from there, you want to go through it like we did for that example. Got your gallons at a standard temperature, and you're going to want to know the specific gravity of the manifest that was of the average of the day from the day before. You want to put that in there, and then what you're going to end up with is you're going to get a certain amount of you're going to end up with tons. You got a certain amount of tons for the beginning of the day. And as the job goes on, there's going to be many trucks coming into the plant, and they're going to be giving us, for every load, they're going to have a manifest like this. Now, this one actually came out of Canada, so there's some metric numbers here, but you get your shipping number, your binder, the type of binder, your quantity. Now, that can be converted down into a pounds figure. And then the specific gravity of the binder is all from this manifest. This particular one, for instance, the 67373 is one of these that is on this cutoff report right here. And so you get these all day. This is for that day, there were several trucks came in. You want to add that all up, divide by 2,000. All we're worrying about in the manifest part of this, doesn't matter what the temperature is, it's what pounds are there, or tons. So in this case, during the day, that's how many tons came in. And so there's things happening during the day here. There's mix adding to the tank, or transports are filling the tanks up, but it's simultaneously being drained by the plant. And so we're keeping track of that. The end of the day, we do the same thing as we did at the beginning. We stick the tank. The contractor sticks the tanks in our presence, and go through the same thing again. We end up with a ton number here again. And so then all that information we can take here now, And we'll add, we got bitumen in storage, so we got that much to start with. We added that much to it. This is what's left over, so we subtract that, and we go through that calculation. So 211.24 was used, tons was used that day in the mix. And so then we can go into here now, the last portion here. We know from the tickets that there was, in this case, 421074 of actual mix put on the produced that day. And then we confer with the asphalt plant or asphalt paving inspector to find out how many tons of waste there was on the road. There may be some tons of waste on in the plant too. And so we add that to it because it was actually produced during the project. So that all gets totaled. And then we can figure out from that, just by dividing this 211.24 by the 4212, we can figure out how much a binder was actually used, or percentage of the binder in a ton of mix. And I believe this job that was 5% was the target, so they got pretty close here. So now we got to kind of figure out the waste, though. We don't want to pay for that oil that's in the waste. There's just a calculation here to figure out how much waste we want to, or actual binder that's in the waste. We want to subtract that from this 211.24. So this is what we actually pay the contractor. We're going to pay them this for this many tons at whatever the bid price was for the oil. And so that's what you get out of a cutoff report. At the end of the day, they're going to also give us what they're required to do in section 154 is give us a printout of every 15 or 20 minutes. I think it's 15 in the spec. I'm not sure why this is 20, but it is. Everything that goes on during the day, during that 10-minute time or 20-minute time period, all the weights, everything that's happening. So we're going to get a printout out of that every day. And this is really, and this is, another form out of the paving workbook, of course, and I just kind of highlight some of the numbers, but this is really where everything is put together. And you've got your aggregate material here, and make sure that it doesn't go out of spec. There's a penalty for that if there was. And the bituminous material, whether it was, the cutoff was right at the target, or if it had any problems with variability, and then the compaction numbers and things of that nature. So that's what that form is. And then when it's all done, everything is done for the day, then you can actually enter all your information from the paving workbook into the materials Dropbox, Excel version. And then plant safety, they're dirty, they're loud. I mean, they're just a lot of things that you got to watch for. And the danger of burns and the possibility of fire and explosion, presence of moving conveyors and other machinery. Unsafe conditions should be brought to the attention of the contractor for prompt correction. And so the inspectors should make sure that they're following the contractor's protocol as well as far as safety when you're walking around these plants. You want to make sure you have all your protective gear on when you go out of the lab.